Hi class, let's take a look at problem 7. Now in this situation, this is what we technically have. So we have a total of 1, 2, let me just label it as 1, 2, 3, and 4 letters. And they're going to be arranged. The good news is that we only have 4 letters and there's one of each. So let me rewrite it as total letters equals to 4, and each letter has one value. So each letter has one value. Now, because we're talking about simple letters and they're being arranged and they're considered to be groups, in this case, order matters, but this is the proper formula that we're going to be using. The total number is going to be how many letters we have. Each of these ends represents how many letters of each we have. So in this case, for the total permutations, this is going to be equal to 4 factorial, and each of these actually contains 1. So the A represents your n is equal to 1, your n's of 1, your B is your n's of 2 is equal to 1. Your C represents your n's of 3 is equal to 1. And your D represents your n's of 4 is equal to 1. So technically at the bottom, you're going to have 1 factorial times 1 factorial times 1 factorial times 1 factorial. Technically, the values of 1 factorial is equal to 1. So this is just equals to 1 factorial over 1, or 4 factorial. Please take a second and evaluate 4 factorial. I'm getting 4 factorial is equal to the values of 24. Remember that all of these, we need a sentence that mentions total permutations. And in this case, total permutations for the letters A, B, C, and D happens to be 24, or you can mention 24 arrangements. So make sure that all of your answers contain some sort of a word here. I'm providing the formula here, and then some sort of a final sentence. Let's move on to problem 8, which is very similar to problem 7, but in this case, we have a little bit of a difference. So total letters, we have, in this case, it's going to be 3 and technically 3 H's and 2 T's. So total letters is equal to N, and in this case, it's going to be 5. But your subgroups are going to be basically your H's. This is N1, and this is equal to 3. And then N2, this is equal to 2. So total permutations is equal to, in this case, we're going to have a 5 factorial. And remember that in the formula, we technically have the multiplication of each of the groups. So for this one, on the previous one, we just had a single letter for each of those. And this one is going to be slightly different. You technically have at the bottom the 3 factorial for the H's and the 2 factorial for the T's. So this is equivalent to, you're just going to punch it into the calculator as 5 factorial over 3 factorial times 2 factorial. Please evaluate and make sure that you place the parentheses at the bottom, and you may need the times. So let me evaluate it here, and I'm getting the total value of 10. Same as we did before, we need some sort of a sentence. In this case, we have 10 permutations or 10 arrangements. That's actually it for example 8. Let's move on to the next problem. Example 9, it's talking about arranging a total of 7 books. So in this case, total different arrangements, it's going to be equivalent to the following. So total it's going to be equal to, let me actually rewrite it. Now this is what we have. You have a total of, well, 7 books. So this is going to be 7 factorial, or you could also label it as n is equal to 7 and r is equal to 7. Order matters. So if order matters, in this case, you could be using the permutation rule, which is this one. Since you're arranging the books and it's just 7 books, order happens to matter. In any case, you would be evaluating 7 P7. Please evaluate those two. And you're going to end up with a total of 50/40. And then for this one, let me just put the sentence. So I'll rewrite it as 50/40 ways. That's a lot of ways to arrange 7 books. Now remember that order matters, so that's why we end up with a large amount. That's actually it for problem 9. Let's move on to 10. Now 10 is a little bit tricky because of the following. Let me just make a sketch. So you technically have 8 people. So I'm just going to say that the people represent the following values for each of the subjects. So 1, 2, 3, 4, 5, 6, 7, and 8. Now here is a possible misconception. When you're actually getting committees, you're actually putting the subjects into groups. So let's say that you mentioned that group number 1 is composed of the following subjects. So in this case, I'm just going to say subject 3, 4, and 5. So in this case, 3, 4, and 5. Now, if you were to do the selections, if you were to put the names in some sort of a bag and actually perform the selections, and you select 3, 4, and 5, technically that's group number 1. If you do another selection and you happen to select instead of 3, 4, and 5 in that order, so technically 4, 3, and 5, it is still representing the same group. So in this case, because you're doing groupings of people of 3s and you consider these 3 individuals as a unit, in this case, order doesn't matter. So the proper formula to use here is n is equal to a total of 8 subjects, r is equal to a total of 3, and then the total committees is equal to 8C3. Please evaluate that. And I'm getting that this is 56. Same as before. Let's actually come up with a sentence. In this case, we end up with 56 committees. I'm just going to rewrite it as groups. And once again, this one's a little bit tricky because it kind of sounds that order matters, but since you're viewing a total of 3 subjects as a group, order doesn't matter. You could be picking them in a different order, but they end up being the same committee. Let me double check the time. Actually, I'll put the other problems in another video. So that's it for this one.